So far, we've taken a look at bundles and how they work and how they're created. From there, we took a look at how we can create things inside of bundles when we create components and services. Now, we're going to take a more formal discussion or formal take on how features are shared amongst different bundles in the OSGI world. So let's go ahead and do a little bit of exploration. So when we create applications in the OSGI world, generally speaking, since we're working in a more modular fashion, we can create these applications using multiple bundles or multiple modules. So that way we can provide a loose coupling of all of these different parts, as well as making them reusable. So by default, bundles have a private visibility. So the idea here is what's inside of the bundle stays inside of the bundle by default. So the question is, how do we expose the features and functionalities of a bundle to other bundles inside the OSGI framework, the OSGI container? So let's first talk about what a feature is. We don't want to be confused with different types of features that might exist elsewhere. So when we talk about a feature, we're usually talking about either a package, a class, or an OSGI service or component. So we don't want to confuse it with features that may exist elsewhere. So usually that's what we're going to be referring to as features. So when we're sharing features between different bundles, there's a couple different ways that we can do so. So the three big ways is using the header within the manifest file export package or import package. This is going to do just that. We're going to be exporting a specific Java package or importing a specific Java package. The second way is through the provide capability or require capability. This too is also in the manifest file. And then finally, the last one is require bundle. So you can say this specific bundle and all of its content is what I require, is what I need. So let's go into more detail. So the most important header or the most commonly used header we're going to be using is export-import, so export package or import package. So this is the way we can share Java classes amongst the different bundles by exporting the whole package and everything in it, right? So this is very explicit, right? So we're saying I am exporting this package, Liferay training OSGI service API, to the OSGI container. Any other bundle is able to import it. And so we see down here on the next part, we can import that specific package. So these are all defined within the manifest file. From there, let's go ahead and take a look at the next methodology, the next way of sharing features. So the next way is through provide require capability. Now this one's a little bit interesting. What capabilities help us do is it's a way for us as developers to describe what's going on with the bundle that we are deploying into the OSGI container. We get the opportunity to describe what does it do. Is it an OSGI service? Maybe it's a Liferay service. Maybe it's a Liferay service for the document library. So we get the opportunity to describe the actual capability using metadata, provide capability. So when we are describing the capability within the manifest file, it's going to be two main parts or two main attributes. The first part is a namespace. So this is the unique ID. This is the way that we can uniquely identify our capability. So typically speaking, it's going to look like a package name. And then from there, you can describe its attributes. So again, with the example of like a doc library, right? You can say my namespace is for the doc library. My attribute is to import specific content. And you can describe all of that with the provide capability header. So something like this, for example, So let's say we have two separate OSGI bundles. So one OSGI bundle, it's providing a specific capability. We're saying its capability is called COM Liferay Training Module. So that's the namespace. That's the first part. The second part is its attribute. So we can say string LaTeX or latex, depending on who you talk to. On the flip side, you can then require that capability. So COM Liferay Training Module, and then you can use the filter using LDAP filter syntax to select specific attributes. So let's solidify this a little bit more. Let's say I am creating an LMS system. Okay, so I'm creating this LMS system and I want to use LaTeX to generate the slides as well as the book. And so I put all of the functionality that I want to create a training module within my OSGI bundle. Now I want the OSGI container to know, and I want other developers to know as well, that I have this bundle that's going to help me create training modules. So I'll provide the namespace, COM Liferay Training Module. And I'm going to say the attribute of this is LaTeX. So within the bundle, it's going to have all of the code and fun stuff to help us generate the book and the slides based off of LaTeX. So maybe I have another bundle that has another bundle that's going to be used to help create the training module. So I want to use that module that has all of the LaTeX, or I want to use all the bundle that has all the LaTeX within it. So I want to target the bundle that provides the capability I'm looking for. So that's what require capability helps us do. So all of that to say, provide capability allows us to provide a specific string that can be targeted by using another header called require capability. Okay, so it's a little bit more robust than export-import. Export-import is restricting just packages, whereas the capabilities, we are targeting that specific keyword we specify within provide capabilities, right? And it allows us to be a little bit more creative with it as we are able to use LDAP filter syntax to pinpoint a specific capability we may want to use. When we are developing over in the Liferay world, one thing that we need to be a little bit careful of is when we start developing in the Liferay world, we're going to be using Gradle in our situation. And so there's going to be a juggling of what's going to happen over in the manifest file and BND tools and what's going to happen over in Gradle. Now, in this case, when we define a specific dependency over in a file called build.gradle, BND tools generally takes care of that dependency that's specified within build.gradle. Right, if you want some more details about provide and require capability, Ray Auger, one of our architects here at Liferay, actually wrote a blog post about require and provide capability. So it's a pretty good read, right? If you have time, feel free to read it. Right? If you want to put your kids to sleep, you can read it to them, right? Kind of two birds with one stone. So with all that being said, let's go ahead and take a look at a demo of requiring and providing capabilities. All right, let's go ahead and take a look at how we can use the provide and the require capability to share features with our different bundles. So this is going to be a pretty simple demonstration here. What I have done is I've created two bundles already. One of them is called OSGI require, and the other one is called OSGI provide. So OSGI bundle require, OSGI bundle provide. And so what I've done over here in the require is within the bnd.bnd file, I have typed in this require capability. And so when I deploy this bundle, what's going to happen is the OSGI container is going to try to find another bundle who has this specific capability. And so I've kind of fudged this a little bit so that it's not all there. So what's going to happen when I deploy the OSGI bundle require is that it's going to throw an error. So it throws an error here, and it shows the specific error over here in this pop-up window. It's basically just telling us that, hey, I have an unresolved requirement. I am looking for a bundle that provides the capability, COM Liferay training module builder. And if I type LB here, I'll type LB. What I have done here is I've actually changed the provide capability of the provide bundle so that it's not the same as what's required. So all I've done here is I added an S after builder. So if I remove the S and then I save the file, and then let me go ahead and launch the provide here. Let's do a quick double check. Let's see if it's all good. And yeah, once I've saved, it has auto deployed for me, and I see that the OSGI bundle require is now in the resolve state. So this just means the bundle is ready to go. I just need to start it. And from our previous exercise, we know how to do that. I can do start followed by the bundle number. In this situation for me, it's the number 1. And then when I type LB one more time, we see that my OSGI bundle require is now in the active state. And so now the provide and the require module are now sharing features amongst one another. So now that we have seen how providing and requiring capabilities happen, right, let's go ahead and move on to the third way in which we're able to share features amongst our different bundles. So the last one is require bundle. This one we mentioned last because what ends up happening is we create a very tightly coupled relationship between another bundle, right? We're saying my bundle requires another bundle, right? And so while this is cool in the sense of I can get all of the features of that bundle, again, it provides a very tight coupling to that bundle, and that can be a little bit dangerous. So before we move on to the exercise, let's talk about that require bundle a little bit more, right? We are being tightly coupled. Because of that, if the bundle is changing, right, we need to be able to account for that change, whether it's a name change or maybe a version number change, right? It becomes very tedious to have to micromanage that. So face value, it might seem like a very good tool. It can be, just be careful, use it with caution. All right, so now that we have taken a look at the 3 different methodologies of sharing features, let's go ahead and see how we can implement the most common one, export, import. So we're going to take a look at an exercise using export, import. So in the previous exercise, we actually used it a little bit, right? When we are creating the API and the implementation, right? If we separate out those bundles, we have to export and import, right? So in this part, we're being a little bit more explicit with that. So in this exercise, it's going to be pretty simple. We'll have one bundle that exports a package and another bundle that's going to import it, right? We're going to be doing this again and again and again as we create services in the OSGI world. So we're going to take a look at that, as well as creating the OSGI service as well, using declarative services and BND tools to help us out along the way. So let's take a look at the steps a little bit more than last time. We see there are 7 steps, but it's not going to be too bad. We're first going to start off by creating our API bundle, and inside of the API bundle will be the interface. Once we create the interface, we're going to say, I want to export the package that contains the interface. So we define that over in the manifest file. So finish the API bundle, we then move on to the implementation bundle. So we'll create that implementation bundle. We'll then go over to the manifest file and import the package that's being exported by the API bundle. So import the package from the API bundle. We'll then create the implementation class to implement the interface. So API bundle, implementation bundle. Once we take care of those two, we'll then run and test it to make sure that everything is all squared away. So let's go ahead, we'll jump over and take a look at what this exercise has to offer for us.